Hey gang, today we're going to continue with some exponential functions, looking at word problems and creating a function that relates to the word problem. First, let's review what we did yesterday. So the directions say find the exponential function that goes through the following set of points. So remember, we need that equation. It's exponential, so right away we think y equals ab to the x. This is exponential because x is the exponent. We want to go through the process of canceling out a to solve for b, then plugging that back in to solve for a. So we start by setting up our ratio. 128 equals ab to the eighth over 32 equals ab to the sixth. And again, I got those right from the coordinates because this is the x and this is the y. This is also an x and this is also a y. So now we want to simplify this. We can cancel out the a's. 128 divided by 32 is 4. So we get 4 equals, subtracting the exponents, b squared. Take the square root, and b equals 2. Now we substitute that back into one of the two parts of the ratio. So we can do 32 equals a times 2 to the sixth. So 32 equals 2 to the sixth power is 64. So it's a times 64. Divide by 64. And a equals 32 over 64, which hopefully you know is 1/2. So then we get our equation, y equals 1/2 of 2 all to the x. Okay, and if I pulled up my table there, I could quickly make sure that I did that correctly by doing 0.5 times 2 to the x, pull up my table, and look for those two coordinates. So 6 120 or 8 128 and 632 should be here. And look, there's our 6 132 or 632 and our 8 128 right in the table there. So we know we did it correctly. Okay, so let's try another example, just refreshing our memory. Number 2, same idea, but now we have some negative exponents we have to work with. So we can do 750 equals ab to the negative third over 30 equals ab to the negative first. Divide 750 by 30. We can do 75 divided by 3 because those zeros cancel out. So we get 25 equals b. Remember, we do negative 3 minus negative 1. So that's like negative 3 plus 1. So that's negative 2. So now we have to do the negative second square root of 25. We can use our calculator to help us do that if we're not sure how to do it. So we go back to math choice 5, so we can put in our exponent or our degree there. So negative 2 with 25 under the radical equals 0.2. I can change that to a fraction by pressing math again, choosing choice 1, and enter, and I get 1/5. Which makes sense because the square root of 25 is 5. The reciprocal of that is 1/5. Now we plug that back in, so we could do 30 equals a times 1/5 to the negative first, which is 30 equals, remember the reciprocal of 1/5 would be 5. That would get rid of that negative first, so a times 5, divide by 5, and a equals 6, making our final answer y equals 6 times 1/5 to the x. And again, I could pull that up in my table to make sure I've got it the right equation. 6 parentheses 1 divided by 5 all to the x. Pull up my table, and we want to look for those two coordinates. Negative 3 is 750, and negative 1 is 30. So we did it correctly. All right, so now we're going to apply this to some word problems. I'm going to do 2 with you, and then you're going to try 1 on your own before starting your exit tickets. So Mr. Moran owns stock in Green Mountain House Coffee. He started his stock with $25, and it has continued to grow exponentially each year. 5 years after he purchased the stock, it is worth $6,075. Write a function rule that models the growth of his stock. Okay, so let's talk about that first. So we have two coordinates. We have 0, 25, because he started at 25, and then we have 5 years later is 6,075. So we can use our equation, 6,075 equals ab to the fifth over 25 equals AB to the 0. A's cancel out. We get 60/75 divided by 25 equals 243. B to the 5th, because 5 minus 0 is just 5. Then we do the 5th root of 243. So we do math, go down to choice 5, put 5 in for our root, and 243 under the radical, and we get 3. So B equals 3. So now we can plug that back in, but it's kind of obvious that our 0 value is 25. So we actually have our equation here, but let's just prove that we've got it right. If we do 25 equals A times 3 to the 0, that's 25 equals A times 3, because any power or any number raised to a power of 0 is just itself. So, or is 1 rather. Oh my goodness, I messed that up. Anything raised to the 0 power is 1. Divide by 1, and we get A equals 25. So our equation is y equals 25 times 3 to the x. So then it says, does this model growth or decay? Obviously, this is growth because we're multiplying by 3 repeatedly, which means it's going to continue to grow. And then something new here, it says, what is the average rate of change over the domain of 0 to 4? So domain is just talking about the x values between 0 and 4. Average rate of change is finding the slope, basically, from 0 to 4. So we know the 0 coordinate already is 0, 25. So we have to find the 4th. We can do that by pulling up the table. And we have our equation, which is 25 times 3 to the x. Pull up the table, find the 4th. We can check too to make sure we've got this right. There's our 0, 25. Our 5 is 60, 75. Our 4 is 20, 25. And find the slope or average rate of change just between those two. So this is going up 4 as this goes up 2,000. And 2,000 divided by 4 gives us our average rate of change there, which would be 500. Okay, so our average rate of change between 0 and 4 years is $500 per year. We could add in if we wanted to. So on average, the stock is growing by $500 per year in that time frame. Okay, so again, it's using the same idea of what we've been doing yesterday and the day before, looking at creating those functions. Let's see if we can do one more. Number 4. So here we have Mrs. Becker purchased a new car for $32,000. So since she's purchasing it, that is our starting value, or our 0 value. The value of the car depreciates exponentially each year. After 4 years of owning the car, it is now worth $20,995.20. Write a function rule that models the value of her car after each year passes. Okay, so does this model growth or decay? Right away, it's saying it depreciates, so it should be decay. We can note that again later. And then we have to find the average rate of change from 0 to 3. Let's start by finding our equation. So again, we have 20,000, or let's start with the bigger number rather. 32,000 equals AB to the 0 over 20,995.20 equals AB to the 4th. A's cancel out. And if we do 32,000 divided by 20,995.2, we get this crazy number. But if we press math rather, and go to fraction, we can turn that into a fraction. And it's that really big number right there. But we're going to use that. So we get 1,000, or 10,000 rather, over 6561 equals 0 minus 4 would be b to the negative 4th. So now I want to do the negative 4th square root So I would go back to our math, go down to choice 5, enter in -4, and then underneath that fraction, so we could do 1,000 or 10,000 rather, divided by 6561, close the parentheses, and equals, and we get 0.9. So B equals 0.9 or 9/10. We could use either one of those. So now again, we have enough to write our equation because we know the starting value is 32,000. So we can have our function written as y equals 32,000 times 9/10 to the x. And that is obviously decay because the b value is between 0 and 1. So it's going to be decreasing in value. So now we want to know the average rate of change over the domain of 0 to 3. Again, domain is just referring to the x values. So we know the 0 is 32,000, but we have to find 3. So we go to our y equals. We put in that function rule, 32,000 times 0.9 to the x, pull up the table, and we know we're right because we have 0, 32,000, and we have 4 at 20,995, but if I hover over it, it's at 20,995.2, so we know that's correct. We look at 3, and we want to use an exact value, so it winds up that that number there is exact, 2,300 or 23,328. Now we can find our average rate of change here. So this is obviously increasing by 3. 32,000 minus 23,328 is 8,672. So it's decreasing by 8,672. Find the average rate of change by dividing by 3. And we get 2,890.67, we'll round, per year. So we can say it's decreasing by $2,890.67 per year, which is the average rate of change for this scenario. Okay, so you are going to try number 5 on your own before trying your exit tickets. Please check in with me so you can be sure that you've got it right before moving on.